Hello and welcome to section 3 of our course. In this section, we'll be discussing serialization techniques as well as RPC framework. This is a very important topic for building production-ready microservices. We'll be discussing protocol buffers version 2, protocol buffers version 3. Then we'll be discussing the gRPC protocol. In this video, we will discuss protocol buffers version 2. Protocol buffers is the name of a very popular serialization technique used in applications where efficiency and performance is important. We will start this video by defining protocol buffers. We will explore how to implement protocol buffers in the Go language. Let's get started. So what are protocol buffers? Protocol buffers are a language-neutral, platform-neutral, extensible mechanism for serializing structured data. What that means is you provide protocol buffers, a data structure like this, and then it serializes it in an efficient way, allowing you to take this data and send it somewhere else where it can get deserialized using protocol buffers. Let's dive a little bit deeper to get a more practical understanding. So first, to get to the main protocol buffer page, you can go to developers.google.com/protocol buffers, protocol-buffers, and then to find more information about the definition and the description of what protocol buffers are about, can go click on Learn More. So when we go to Learn More, we see more information about what protocol buffers are about. This is a good read, which I strongly recommend you read, but for our purposes, I'll focus on the practical information that you need to gather in order to write effective code that uses protocol buffers. So, as mentioned earlier, protocol buffers are an efficient approach to serialize important pieces of data into a small and portable format that you can use elsewhere. This is very helpful for communications, as we will be seeing shortly. So the first thing you need to do when you're writing a protocol buffer application is to describe the data that you would like to serialize. And you do that by describing your data in what is called a proto file, which is basically a file with a .proto extension. Typically, the file should look like this. What's seen here is an example of a piece of information describing a person getting outlined in a proto file. So the first keyword we need to pay attention to is the message keyword. So a message is how you would describe a data structure. Person is the name of data structure you would like to get serialized. And then inside the curly braces, you find all the fields that construct your structured data. So in our case, the person data structure has a name field, an ID, email, and then there's an enum to describe different types of phone numbers. And then there's an internal message. This is like an inner class or like an inner data structure inside a data structure where we describe what a phone number is. And in here we have two fields, number and type. And then at the end, for the person data structure, there's a phone field. Now let's go back and look at those fields with more focus. You notice here that the required and optional keywords are used all over the place. There's also repeated. So the required keyword is basically us telling the protocol buffer compiler, which we'll cover later, that this field is a must. It cannot be ignored. when serializing. If there's no value provided for this field, then there's something wrong. Fields with the required keyword are always serialized, whereas fields with the optional keywords are just that, optional. So they don't have to be included in the serialized message that the protocol buffer compiler will introduce. We then have the enum keyword, which is very obvious. We use it to create enums. So you notice here, for every field, there is an ID assigned to it. This is important in order to identify the different fields in our message without having to use their full names. So you notice here that name, ID, and email were 1, 2, and 3. And then if you go all the way down, we notice here the phone number was ID 4. Protocol buffers are extensible, meaning that we can add IDs 5, 6, and 7 in the future in our proto file without breaking backward compatibility. What we need to be careful not to do in future revisions of a proto file is to remove a required field. This is not recommended because it breaks a compatibility, backward compatibility to be specific, of the protocol buffer file. We notice here, as mentioned earlier, that we can have a message inside a message, or a data structure, or a class, or however you want to call it, inside another data structure or class. There's no issues. And then there is a keyword repeated, which basically means a list. So when you say repeated phone number, then I'm basically telling the protocol buffer compiler that there is a list of phone numbers. It will not be a single phone number. Perfect. So that provides a practical description of a proto file. You may have noticed that I mentioned the term protocol buffer compiler. So what is a protocol buffer compiler? It's basically a program that takes a proto file like this and then convert it into a file that could be understood by your programming language of choice. So for example, if I go here to the Go tutorial and scroll a little bit down, you see a command here that starts with pro2c. Pro2c is the name of the program that contains the protocol buffer compiler. So I provide to it a source directory. I provide to it a keyword to describe the programming language of choice that I would like to use. So in our case, we would use this flag, --go_out equals, and then we put wherever we want the Go file to go. And then at the end, we specify what the source file is called. So as we've already covered, the source file will be a proto file. So it will take a proto file and then convert it into a Go file that will go to the destination directory. Let's look at another example here quickly. So what if we are using Python? So if I go to the Python tutorial, scroll down a little bit, we see here that in case of Python, the syntax is pretty similar as in the Go language, except that we use a Python out flag this time. And what this would do is take a .proto file, convert it into a Python file, and then put it at the destination directory. Now, before we start covering some code, it's important to discuss the fact that there is protocol buffers version 2 and a protocol buffers version 3, which are not backward compatible. So if I open version 2 here, so you'll see here under the language guide, a good description of all the syntax you need to use for protocol buffers version 2. And then at the end, you'll find a good description of the data types supported by the protocol. We will be discussing Proto 3 in the next video, so let's not worry about it right now. It's now time we start writing some code. So the easiest way to start with protocol buffers is to go to the tutorial of the language of your choice. So in our case, we're gonna do Go. So if I scroll down here, we see here, the first step is to define our protocol format. In other words, we need to write our proto file. So let's write a proto file for the data we expect for our Dino application. So I have a proto file here prepared. Actually, let's just jump to the proto file, close everything else. And now we can see it. So let's first review the data structure that we used over and over again in the previous section. So in the previous section, when we worked with databases, we used the animal data structure in order to define the properties of an animal in the Dino zoo. Each one of our animals has an ID, an animal type, meaning the dinosaur type for which the animal belongs, the nickname of the animal. So for Tyrannosaurus Rex, nickname was Rex. And then there was a field for the zone where the animal lives. So the zone is the part of our zoo where the animals of this type live. And then there was the age of the animal. So to define that in protocol buffers, first thing we need to do is to define the package. So the package name here will be the package name that we are expecting the generated Go file to follow, and we will see that shortly. So for now, I define the package as Dino Proto 2, very obviously because we're using Proto 2, protocol buffers 2 for now, and this is for the Dino application. And then for our data structure, we define it as protocol buffer message. It's the same as what we covered earlier. We use a message keyword to define the data structure. We then use the required keyword to describe the fields that are required, and the optional keyword to describe the fields that are optional. So let's assume that ID, as well as animal type and nickname and zone are required, whereas nickname and age are just optional. So for ID, we pick the type int32 for simplicity, and this field will have ID1. For animal type, which corresponds to this, we'll have a type string, obviously, and it will have ID2. Nickname will be a string, ID3. Zone will be of int32 and ID4. Age will be of int32 type and ID5. Perfect. So with that, we describe our data structure in protocol buffer language. Now we put this in a .proto file as discussed previously, and I call it protodata. So protodata.proto exists in a folder called Dino Proto 2, which is a folder I'm using for the protocol buffer 2 representation of Dino data. And this exists under a folder called communication layer, which I created for all the serialization and RPC code. And then that exists under Dino, the Dino folder, which exists in our Go workspace source folder. Perfect. Now let's go back and observe the next steps. So now we defined our protocol format. What should we do? We need to start compiling protocol buffer using the protocol buffer compiler. So to do that, the first step we need to do is install the compiler. So when we go to the download page from the link in the tutorial, you'll find here an option to go to the release page. So because for this video we are working with protobuf 2, we need to dig a little to get the compiler for protobuf 2 instead of protobuf 3. So to do that, we need to go to tags, then hit next again, and here we find the latest version of 2. So we'll need to go to the downloads, and in here, so if you are a Windows user, you'll find a precompiled binary for Windows, which you can just use. However, if you use other operating systems or platforms, then you need to build the protobuf compiler yourself. So this is only a requirement for protobuf 2. However, for protobuf 3, there are precompiled binaries that you can use for platforms other than Windows. So since I'm using a Mac here, my option would be to download that zip file and then build it. Or to be more accurate, build the code included. One important remark is that you can also use a homebrew in case of Mac to obtain protocol buffers version 2. There is a formula for it. However, you'll need to make sure to obtain protobuf version 2 if you use homebrew, since the latest version is version 3. So for now, let's look at that zip file. So that's how the folder looks like. For our purposes, since we need to build the protobuf compiler, we would need to open the readme.md file. So when you open it and you look here, you'll find the instructions to build and obtain a protocol buffer compiler. So I already did the steps to build using the instructions in the readme file. And now, if I try to look for proto-C, actually, I need to use which because this is macOS. It exists in the user local binary folder. If I run proto-C -- version to obtain the version, we see here that it's 2.6.1. Good. So that means that we have the file now and it's ready for use. Again, if you're using Windows, you don't have to worry about building the binary yourself. And that is because there's an executable that already exists and can be downloaded from the page we covered. This one. Perfect. Now let's continue with instructions. So next thing we need to do is install the Go Protocol Buffers plugin. So this plugin works with the protocol buffer compiler in order to generate files written in Go. There's a similar plugin for Python or Java or C# or what have you. So in case of Go, we need to use this command, the popular go get with the -u flag, to obtain the plugin. So let's do just that. And now we have it. So proto-C -gen-go should be installed from this. So let's ensure we have it. So if I go proto-C -gen-go, we find it in my Go path bin folder, which is exactly what it says here. Perfect. Now what we need to do is run proto-C compiler or the protocol buffer compiler with this file. So I had the auto-generated file from before, but let's repeat this. So I'm just gonna delete it. And Let's open this in the terminal and let's follow the instructions. So it says we need to say proto C to call the protocol buffer compiler. Then in my case, I'm just gonna simplify it because I don't want the generated Go file to go elsewhere, and also I'm running this command from the same folder where the protocol buffer file exists. So I can just say dash dash go out. I can say equals dot so that the output goes into the same folder. And then I can just type in the name of the proto file. So the proto file here was called protodata.proto. So let's type that in. So protodata.proto. And it doesn't complain. And now if I go back to VS Code, well, if it allows me, we now see that the file is back. So this is an auto-generated Go file, and it says here very clearly that was created based on the proto file we provided to the protocol buffer compiler. So if I look at the code here, we see here that the package name of this file is the same package name we selected for our proto file. And then if I go down, we see here that there's type animal that is a struct, and that the struct contains the fields we requested. Perfect. So we can see here some predefined methods that, or the animal struct type supports. And we see here some accessors that we can use. So we can get ID, get animal type, get nickname, get zone, so and so on. So now let's write some code that makes use of this file.